Hello everyone, this is a demonstration of how we can solve LPP using Excel. So for this what you need is a solver add-on which you can see under the data tab. If you don't see it, you can go on to the options, add-ins and click go here, and then you should be able to select solver add-on here. Once you click OK, you should be able to see it here, and that's what is needed for solving LPP using Excel. Okay, so what are the steps? So for this problem, what we need to do is create the constraint functions as well as the objective functions. I'm not going to go detail into how to arrive at that, and yeah, you should be knowing this by now. So here are my constraint functions as well as my objective functions. So let's say M1 and M2 are probably the raw materials, and X1 and X2 are the outputs what we need. So let's say we are starting with X1 and X2 values as 1 here. So 6 into 1 plus 6 into the X1 which is 1, 4 into X2 which is again 1 should be less than or equal to 24. That's the first constraint. Same way, 1x1 plus 2x2 should be less than 6. So these are the constraints. I have listed them here and also have the outputs for each of the constraints listed here. And my objective function is here. So 5x1 plus 4x2 should be maximized based on these constraints. So once we have these in cells in Excel, click on solver. So our objective is this output here, D8, which is 5x1 plus 4x2. That should be maximized. So select max here by changing variable cells B3 to C3, which is these two. And my constraints, so how to add constraints here, let me change one of it, and that will tell you cell reference D4, which is this. So 6x1 plus 4x2, this is the output of first constraint, should be less than F4. F4 here is 24. So same way you add all the constraints, select input cell, select the objective cell, maximum, minimum. You can also select the method, simplex LP for example here. You also have other ones. You could also choose this option, make unconstrained variables non-negative, may be needed for some of the methods. So once you do all this, click on solve. So I'm starting with values 1 and 1 and see the outcome at the end of the solve here. Okay, so the solver results here. You can keep the solver solution, click OK. The final outcome is x1 should be 3 and x2 is 1.5. So this is all it is. All lies in how you create the constraint functions as well as the objective functions, and then just running the solver. That's it. Thank you.